Hello guys, how are you today? So today I'll be explaining the chemistry AMS quiz for term 3 week 4. Okay, this is like I believe the last AMS quiz we had, but I don't have a problem with explaining it again, it's fine. So guys, before we start, I would like to put the comments of this video. So we start off with this comment over here. Why are ghosts so bad at telling jokes? Because they are transparent. Ha ha ha, I have no friends. Your joke is very dad joke vibes, And you don't say you don't have any friends. I'm more than happy to be your friend, by the way. Okay, moving on to the next one. Very straightforward, Mr. Shrimp. I hope your shrimp farm goes well. And then finally, the third comment. Okay, I found this very funny and interesting because it's actually really smart. Because you get to see, are you patient enough to withstand anyone bothering you or anything? So yeah, it's like a very psychological thing to do with your friend. And anyways, thank you these three people for putting your actually funny comments. I hope there will be more in the future, so to put in future videos. And anyways, let's just continue with the video. So anyways, let us start with the first question. In the first question they said, an alloy is a solution of a metal with other metals or non-metals. Which of the following best describes the structure of an alloy? Okay. Usually, when you are dealing with an alloy, it is what? It is a solution of a metal with other metals or non-metals. Examples of alloys, you have brass, you have bronze, you have a lot. You have steel, for example. So these are some examples of alloys. Okay, they are either a solution of metal plus metal or metal plus non-metal. Okay, now what happens in the alloy? Let us say this is the metal of one, the atoms of one metal, okay? And then we mixed it to make a solution of metal that is red and another metal that is blue. So what's gonna happen is either the blue metal is gonna take the place of some of the red atoms, okay? So if that's the case, it will be something like this. So the other metal, which in this case is the blue metal, is going to take the place of some of the particles of the red metal. So we call this what? We call this, it's going to replace some of the host atoms in the lattice. Or if we are dealing with a non-metal, the non-metal could fill in these spaces, okay? Or it could what? Or it could occupy the intersection, or I don't know, this word, the interstice, whatever this is, the spaces between the neighboring host and which is the metal atom. So the two most important things whenever you define the structure of an alloy, it's either atoms of another metal or non-metal will occupy the spaces of the host metal, so the gaps, or they will replace some of the host metal atoms in the lattice. Okay, so that is it for question number 1. We move on to question number 2. In question number 2, it says, an aluminum alloy is used instead of pure aluminum in aircrafts. Why is aluminum alloy used instead of pure aluminum? Okay, let's think logically. We need what? Aluminum. Why is the aluminum alloy used in aircraft? So let us read the options. Aluminum alloy is stronger than pure aluminum. Of course, this would definitely be a reason why we would use it in aircrafts. Then, aluminum alloy is more abundant in nature than pure aluminum. Okay, if it's more abundant in nature, but it's not gonna benefit us, why would we take it? So you have to think in this manner. Is it gonna benefit us? What is the benefit if it is more abundant in nature, if it's not gonna help us in the production, It has a lower melting point than pure aluminum. This is also wrong because imagine the aircraft going at high speed, so the temperature will increase. If the temperature will increase and we use the aluminum alloy, it might melt and it might damage the aircraft. So definitely for sure, we do not use it because it has a lower melting point. And then finally, aluminum alloy is more reactive than pure aluminum. If it is more reactive, then imagine that the aluminum alloy in the airplane or the aircraft, it's flying in the air and then it might react with the oxygen. If it reacts with the oxygen, it could damage the aircraft and it could lead to some very dangerous things. So definitely for sure, the first option is correct. We move on to question number 3. Which of the following are general properties of transition metals? When we are talking about transition metals, Okay, here I open my trusty periodic table. I love this website, by the way. If you want to open it, it's ptable.com/whatever. You can see it up here. But basically, look, you can click here, and for example, you choose scandium. It will give you all of its properties and some other interesting things it could do. It could show you, 1 second, where was it? I think I clicked on it, the electrons. It will show you, look, it will show you what it looks like, the electrons and whatever, and its configuration. You have the simple configuration and the expanded configuration and whatever. So it's a very cool website if you guys would like to use it. But I only came here for what? For the transition metals. The transition metals start from here all the way until here, okay? So everything in this light pink or salmon pink color, these are transition metals. We have some very important properties about these transition metals. These important properties could be what? They have high melting points, so high melting point, high boiling points. They also have high densities. We are saying high compared to what? High melting points, boiling points, and densities compared to the alkali and alkaline metals. They have more than one oxidation state, more than one oxidation state. They form what? They form colored compounds. Colored compounds. They're also, I believe they are less reactive. They are less reactive than the alkali and alkaline metals. Why is that? That's actually a very, very important question. So look, over here, you will need to look at the electrons. So, or the oxidation number. So over here, this is +1, +2, +3, +4, -3, -2, -1, and 0, okay? So basically, the more reactive ones, they are gonna be the alkali metals and the halides. Why is that? It is because of their oxidation number. So, for example, the alkali metals with hydrogen, they have an oxidation number of +1, meaning they need to lose one electron. The halogens, the halides, which are fluorine, chlorine, bromine, iodine, etc., they have -1. That means they need to gain one electron. And the more you move, you will see that the more electrons will need to be gained. So if you move over here, you will see, okay, you have chromium, for example, you have Cr2+ and Cr3+. Or for example, iron, where is iron? Iron is Fe. Iron, you have also Fe2+ and Fe3+. But as you can see, these numbers are greater than 1. So that means these metals, they will need to lose what? They will need to lose 2 electrons or even 3 electrons. And it's definitely bigger than 1. So definitely it's gonna be harder and it will need more energy for them to lose these electrons. And because of this, because they need more energy to lose the electrons and react, that is why they are less reactive than these metals over here. So it was just like a quick explanation, a brief explanation. But here, this is just what you need to know about the transition metals. So if we go back to the quiz, which of the following are general properties of transition metals? They have a higher melting point than other metals, so you don't choose this. Oh, I forgot to mention, they do have catalytic properties. What does it mean by catalytic properties? Catalytic properties means they act as a catalyst, or they speed up a reaction without being used. A very important example is in the Haber process. We use one of the catalysts, it's iron, finely refined iron. So yeah, for sure, it does have catalytic properties. They form only white compounds? No, they form colored compounds. Each may have more than one oxidation state. This is true. And they are denser than other metals. This is also true. So the 3 correct answers are they have catalytic properties, they have more than one oxidation state, and they are denser than other metals. We move on to question number 4. In question number 4, it says an aqueous solution of hydrochloric acid. So look, an acid is reacting with what? Is reacting with calcium carbonate. What you need to know, very, very important. Whenever you see calcium carbonate, you will focus on the carbonate ion. Anytime an acid will react with anything that contains a carbonate ion, there's going to be a release of carbon dioxide and the water. So carbon dioxide and water and a salt. So the release of the carbon dioxide, there will be effervescence or fizzing, or there will be bubbles formed. Water is just water. You can test for water by either using the cobalt chloride or the copper sulfate. They are anhydrous, by the way. And then you have a salt. So, which of the following is the expected observation? Definitely formation of bubbles. Why? Because the calcium carbonate is going to release carbon dioxide. Okay, what are the products for the net ionic equation of the reaction? Okay, the net ionic equation, we know it is HCl reacts with CaCO3. Whenever they say net ionic equation, they mean the ones that will not be aqueous, okay? They want the ones that will form something that is not aqueous. For example, if you separate them into their ions, you have H plus and Cl minus. And then here you have Ca2 plus and CO32 minus. Okay, but we will not take the ions. Why? They said they want the products of the net ionic equation. So for now, we're gonna take it like this. You're gonna take that the H plus, the cation, is gonna react with the anion, which is CO32 minus. And then you have that the anion, Cl minus, is gonna react with the cation, Ca2 plus. So if you react them together, you're gonna get that when H plus reacts with CO32 minus, you're gonna have a product form. So H plus CO32 minus. This product is gonna be carbon dioxide plus water, very simply. And then to balance it, you're just gonna put A2 over here. Okay. Now, however, when you are doing Ca2 plus reacting with Cl minus, it will form an aqueous salt. This aqueous salt is CaCl2 aqueous. Why aqueous? Because like when Ca will react with Cl, they will not form a precipitate, so it will stay aqueous. So they want the products of the net ionic equation. We said whenever we're dealing with net ionic equation, we do not choose anything that is aqueous, so this one we will leave it out, so we will be left with this option over here. In this option it says that we have the two products being carbon dioxide and water. Okay. So now we move on to question number 5. In question number 5 they said drag and drop the following water contaminants to classify them as organic or inorganic water pollutants. Okay, very simply. Inorganic water pollutants, you will have inorganic fertilizers and heavy metals. Whereas organic water pollutants, you will have sewage water and pesticides. Very simply, you need to know this by heart. So sewage water, pesticides, organic. Heavy metals, inorganic fertilizers, they are inorganic. So now we move on to question number 6. Okay, so hydrogen fuel cells work like batteries, but they do not run down or need recharging. Choose the gases reacting in a hydrogen fuel cell. This you should know, that whenever you're dealing with a hydrogen fuel cell, you have only two gases. They are H2 and O2. They will react to form only one product that will not affect the environment, which is water, H2O. So again, H2 and O2 are the only two gases that react together, and they will form one product, which is H2O. We move on to question number 7. Here they said, write the chemical equation for each of the following metals with oxygen gas. Do not include state symbols in your equation. Use the smallest whole numbers to balance the equation. Okay, so potassium will react with oxygen gas. So that means K plus O2 will form a product. How do we know what is the product that will be formed? For us to know this, you will need to take the K, you will take its ion form, which is K plus, and you will take the O2, you will take its ion form, which is O2 minus. Now you will do the crisscross method. After doing the crisscross method, you will get K2O. So K plus O2 will give us what? Will give us K2O. Now, as you can see, they said do not include state symbols, so that's good. For now, we will not include these state symbols, but pay attention in the exam. If they ask you to include state symbols, you have to, okay? They said use the smallest whole numbers to balance the equation. As you can see, it is not balanced. In order to balance it, you can see over here we have O2, and over here we have only one O, so we're gonna put A2 over here. Now for the K, we have 2 times 2, which is 4K, so you just need to put a 4 over here. So that is the balanced equation, which is 4K plus O2 will give us 2K2O. So 4K plus O2 is gonna give us 2, what did I put? Add 2 K2O. Okay, that is it for part A. We move on to part B. Magnesium, Mg, reacts with oxygen, O2 to form what? Take their ions. You have Mg2 plus and O2 minus. Do the crisscross method. You will get Mg2 O2, but since they are the same number, you can cancel it out. You will take the simplest form, so it will become MgO. So the product we are dealing with is MgO. Okay? Now, as you can see, it is not balanced. We only have we only have one oxygen over here, whereas over here we have two oxygens. So you're gonna put A2 over here, and very simply for the Mg, you're gonna put A2. So the final balanced equation is 2Mg plus O2 will give us 2MgO. So 2Mg plus O2 will give us 2MgO. We move on to part C, iron Fe. Fe forms Fe3 plus ion. Okay, so here they said that iron Fe is going to react with O2 to form a product, but they gave us a hint. They told us that the iron will form Fe3 plus ion. If that's the case, then the ions are going to be Fe3 plus and O2 minus. You do the crisscross method, you are going to get Fe2O3. So the product we are dealing with is Fe2O3. As you can see, it is not balanced. We have 3 oxygens over here and only 2 oxygens over here. So in order to balance it, we're going to put a 3 over here and a 2 over here. Now for the iron Fe, you can see you have 2 times 2 iron, so it is 4 iron. So the balanced equation is going to be 4 Fe plus 3 O2 gives us 2 Fe2O3. So iron Fe is 4 Fe, okay, plus 3 O2. Okay, this is the balanced equation, will give us 2 Fe2O3. So that is it for question number 7. We will move on to question number 8. In question number 8, they said chlorine, Cl2, is added to methane, CH4. Choose the correct answers to complete the following. The reaction between methane and chlorine can be speeded up. Okay, so whenever we're dealing with methane, you will know that it is directly what it is, an alkane. And if you check its formula, it's following the formula of CnH2n plus 2. So definitely it's going to be an alkane. And when you are dealing with alkane, when it's reacting with another substance, for example, in this case, it's reacting with Cl2 chlorine, it will undergo a process called substitution. So what's going to happen is that some of the hydrogens from the alkane are going to be replaced with the other product, which is chlorine. Okay, it can be speeded up by something called UV light. So over here, this is UV light. And very simply, this is all you need to know. So the reaction between methane and chlorine can be speeded up by UV light. This reaction is called a substitution reaction because chlorine takes the place of a hydrogen atom in methane. Now, some of the possible products, when you are choosing the products, you have to pay attention, okay? You can never have in the middle anything other than carbon. So in the middle, it always has to be carbon, okay? So definitely this is wrong because in the middle we have chlorine. Only in the middle we can have carbon. Now, one of the products that will be formed is either going to be C, and then you will draw the 4 bonds. You have HHHCl. This is one of the products being formed. Or C, you will have ClClHH. Or you can have even ClClClClH, or even you can have ClClCl and Cl. Okay, you can have these different 4 products. Another product, so mainly you're going to have 2 products. You're going to have the methane being replaced with the chlorine. So we call this chloromethane. Or chlorine, I don't know what to call it, okay? And the second product is going to be what? The hydrogen. You removed the hydrogen. Where will this hydrogen go? The hydrogen will go back to the Cl. So it was ClCl. You took one of the Cl, you gave it to the methane, and instead of the chlorine, you will put an H, so it becomes HCl. So this is the other product being formed. So basically from here we have only 4 answers. It's this one, this one, this one, and this one. That's it. You can click here to check. So that is question number 8 done. We move on to question number 9. Okay, this is very important. They said ethene, C2H4. So directly you know this is an alkene, because it follows the structural formula CnH2n. Okay, it has the following structural formula. They said ethene will react with hydrogen gas H2 at a high temperature and pressure. Okay, so look, if ethene, an alkene, is reacting with something else, what's gonna happen is a process called the addition process, okay? This type of reaction is an addition process. Basically, what's gonna happen is we're gonna break the double bond, and half of the bond will go here, like this, and the other half will go like this. And then the two hydrogens in this case, the H2, one H will go over here and one H will go over here. So the new format looks like this. So C, single bond C, 1, 2, 3, 1, 2, 3, hydrogen, 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 hydrogen. So the formula is gonna be C2H6. And as you can see, it's gonna be an alkane because it follows the structural formula of an alkane, which is what? Which is CnH2n plus 2. Okay, very simply. So this type of reaction is an addition reaction. The chemical formula that we get as the product of the hydrogenation of ethene is C2H6. The homologous series, we said that we produced an alkane. Okay, now the correct classification. When we are dealing with alkanes, we know that alkanes are only saturated hydrocarbons, whereas anything other than alkanes, they can be unsaturated hydrocarbons. What is the difference between saturated and unsaturated? Saturated means it has only single bonds, whereas unsaturated means it does not have only single bonds. It can have double, triple, whatever bonds you want, okay? But not only single bonds. So alkanes, they are saturated hydrocarbons. Okay, for question number 9, they said ethanol, C2H5OH, can be produced from ethene under certain conditions. Choose the reagent that converts ethene into ethanol. Very, very important question. So ethene is what? Ethene is C2H4. Will react with the product to give us what? Ethanol, C2H5OH. Let us see what is the extra that has been added. We have 2 carbons over here. Over here we have 2 carbons. We have 4 hydrogens over here. Over here we also have 4 hydrogens. So you're gonna be left with 2 H's and 1 O. So the extra product you added is H2O. But it has to be at a very, very, very high temperature. So very simply you can say steam instead of H2O. So definitely steam is the reagent that will convert ethene into ethanol. Or, if you want a general equation, alkene plus steam will give you what? Will give you an alcohol. Very important. We move on to part C. In part C, it says ethene reacts readily with chlorine, Cl2, at room temperature. Locate the product of the reaction between ethene and chlorine. Okay, so again, we're dealing with what? We are dealing with the alkene. Ethene, so it's gonna be 2 carbons double bonded, and we're gonna have 1, 2, 3, 4 hydrogen. Now they said what happens, you are adding to it chlorine. So if you are adding to it chlorine, the double bond is gonna break, and now it will look like this: C, single bond C, H, 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 and then bond over here. You're adding Cl2, so what's gonna happen is you're gonna have a Cl over here and a Cl over here. So very simply, our product is supposed to look like this. Okay, we move on to question number 10. In question number 10, it says sulfuric acid, H2SO4, is manufactured whatever by the contact process, etc., etc. So they just gave you this. They said give the chemical formula for product A. As you can see, product A, what's happening to it? It is sulfur dioxide. What is being added to the sulfur dioxide? It is oxygen. When you are adding oxygen to sulfur dioxide, what's gonna form is sulfur trioxide. So it's gonna be S, and then O, and then 3. So SO3. Notice it is not balanced, so they did not ask us to balance it. Since we were not asked to balance it, we're not going to be putting any kind of number in front of it so that it will not lose our chance of getting the mark, okay? What conditions of pressure and temperature are needed to produce product A in the contact process? Okay, so very simply, we need only 2 atmosphere of pressure, which is 200 kilopascal, which is 200,000 pascal, and 450 degrees temperature. Now the catalyst used in this process, because this process is known as the contact process, we use what? We use vanadium V oxide, okay? And we move on to question number 11. In question number 11, they said, whatever, blah, blah, blah. So they gave us this equation, C2H5OH. O, what does this O over here mean? This O over here means that it undergoes oxidation, okay, to produce product X plus H2O. The oxidation of an alcohol, so this over here is an alcohol. The oxidation of an alcohol will always produce what? It will produce carboxylic acid. In addition to what? In addition to water. So, choose the type of reaction described above. It is definitely an oxidation reaction because we're adding oxygen. They said choose the chemical formula for product X. Okay, look what's gonna happen. We said that when we are oxidizing an alcohol, we will produce what? A carboxylic acid. Always carboxylic acid has the functional group of COOH. So you're gonna open the answer and you're gonna see whatever has COOH. You're gonna choose the one that has COOH. Very simply, that's it. We move on to part C. Choose the correct answer. Here you need to memorize. Whenever we're dealing with an acidified solution of potassium permanganate and you add it to ethanol, an alcohol, so remember potassium permanganate in addition to an alcohol, what's gonna happen is that we're gonna change its color from purple to colorless. So keep in mind, acidified solution of potassium permanganate, P permanganate, P purple, okay? It will change from purple to colorless, okay? So purple, colorless. When adding acidified solution of potassium dichromate to ethanol, so remember potassium dichromate to ethanol, so plus alcohol, it will change the color from orange to green. So dichromate, orange, so orange to green. Very simply, that is it. It will change from orange to green. That is it for question number 11. Let's move on to question number 12. In question number 12, they said, electrolysis of molten calcium fluoride CaF2 is conducted using the below apparatus. So whenever we're dealing with something molten, you should know what? You should know that both products will form. What does it mean? If we're dealing with CaF2 separated into its ions, Ca2 plus and F2F minus, it's gonna form the Ca2 plus will form on the negative electrode, which is the cathode, and then the 2F minus will form on the positive electrode, which is the anode, and they will form their respective products. So the cathode will form calcium, metal, and then the anode will form fluorine gas, so F2 gas. This is only the case if it's molten. If it's aqueous, then you have two different cases. You have either if it's concentrated or if it is dilute. I think by now you guys should know what are the conditions and everything. So choose the identity of the element produced at the negative electrode. We know at the negative electrode it is the cathode. We're gonna form the calcium metal, so it's gonna be Ca, very simply. At the positive electrode, which is the anode, we're going to have the anion formed, which is 2F minus. It will form fluorine gas, so it's F2 gas. Okay, F2. Now they want us to write the chemical equation for the half reaction at the negative electrode. At the negative electrode, which is the cathode, it will undergo what? It will undergo reduction, I believe. Okay? Reduction means what? Reduction means the gaining of electrons. So take the ion. After separating the ion, you have CaF2, you will have Ca2 plus and 2F minus. So the Ca2 plus, you will bring it to the negative electrode, which is the cathode. It will be Ca2 plus. It will undergo reduction, so it will gain electrons to form what? To form Ca. So this is the equation over here. And the equation at the positive electrode, which is the anode, you're going to take the 2F minus, you will bring it over here. It's going to be 2F minus. At the anode, it undergoes oxidation. Okay? Now, what's going to happen? The 2F minus is going to lose 2 electrons. So it's going to give 2 electrons in addition to what? To F2 gas. There's no need to put the gas, by the way, so just write F2. So these are the two equations. Over here, it's going to be Ca2 plus 2E minus is going to give us Ca. Okay? And over here, 2F minus is going to give us 2E minus plus F2. So that's it for question number 12. We move on to question number 13. In question number 13, we have something very important. They told us a hydrocarbon is 75% carbon by mass. Find its empirical formula, its simplest formula. So 75% carbon by mass. So let's say the total mass is 100 because it's in percentage. So 75% is carbon by mass. So let's say 75 grams is carbon, plus 25 grams is gonna be hydrogen, and it's gonna give us in total 100 grams of the hydrocarbon. Okay, now what we're gonna do this, over here we have the mass. Let us now find the number of moles. In order to find the number of moles, what we are supposed to do is you're supposed to take the mass and divide it by the molar mass. Molar mass of carbon is 12, plus molar mass of hydrogen is 1, and you're gonna ignore this for now. So now the moles, you're gonna get them respectively to be 75 divided by 12, so it's 6.25 moles plus 25 moles. Okay, now what you're gonna do is you're gonna take the simplest ratio. In order to take the simplest ratio, you're gonna divide both ends by the smaller number of moles. So you're gonna divide by 6.25, okay? So after dividing over here, you're gonna get 1 mole, and over here you are gonna get what you're gonna get, 25 over 6.25, you're gonna get 4 moles. So very simply, you have them as whole numbers. Very important for them to be whole numbers. So it's gonna be C1, you do not write 1, so it's gonna be C, and then H4, so very simply it is CH4. If you want to double check, I like to do it like this. I would like to take the mass of carbon, which is 12, over the total mass of the compound, which is 12 plus 4. So do 12 over 12 plus 4, okay? And then multiply it by 100, so times 100, you're gonna get then 75%. Just like that, you finished this question. We move on to question number 14. Okay. In question number 14, it says tetrafluoroethene of the following structural formula undergoes polymerization, forming the polymer Teflon. Give the name of the type of polymerization ethene undergoes. Look, as soon as you see this structure, you will know that they will break the double bond. And when the double bond is broken, we know that this is what? An addition polymerization. They said give the chemical name of polymer Teflon. The chemical name of the polymer Teflon is going to be very simple. First of all, how to name any polymer? It's going to be poly and then the name of the monomer. The monomer in this case, it is tetrafluoroethene. So it's going to be polytetrafluoroethene. So polytetrafluoroethene. There you go. I have it saved. Okay. Part C. If N molecules of tetrafluoroethene are polymerized, so they want the polymerization, locate the correct representation of the repeating unit. Okay, so they want us to make it into a polymer. To make it into a polymer, we will break the double bonds, so it will become C single bond C, F, 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 okay? You will open the brackets like this, and like this, and before you would put an N over here, now you will put an N over here. So very simply, this is what it is supposed to look like. So it will be this one over here. We move on to question number 15. Okay, in question number 15, they said propanoic acid. This is what? A carboxylic acid. Carboxylic acid reacts to the ethanol, which is an alcohol, according to the below equation. So always when a carboxylic acid reacts with an alcohol, it will produce an ester in addition to water. Okay, so they said choose the name of the forward reaction. The forward reaction is going like this. It's going from the carboxylic acid plus alcohol. So the forward reaction is going to be known as what? As esterification. Now, a condition you need for esterification is concentrated H2SO4. Okay, now the forward reaction is known as esterification. Okay, so let me just put it here. Esterification. Now, the backward reaction, what is it gonna be? The backward reaction is what? The backward reaction is the addition of water. This is how I do it. Because it is the addition of water, then we will name this what? We will name this hydrolysis. So the backward or reverse reaction is known as hydrolysis. They said give the name of product A. Okay, this is very, very important. Whenever you are naming an ester, which in this case is product A, to name it, it is gonna be the alcohol carbon, so the number of carbons of alcohol, and then you will put il, okay? And then, in addition, you're gonna add to it what? The number of carbons of the acid, and then you are gonna put ano weight. So for example, over here you will see, okay, this is the acid and this is the alcohol. So I will take the alcohol, I will take how many carbons do we have? We have only 2 carbons, so that means it's gonna be F, okay? And the acid, how many carbons I have? I have 3 carbons, so it's gonna be prop. So remember, for the alcohol, it is F, and then you put YL, so ethyl. And then for the acid, you're gonna take prop, and you will put ano weight. So it's gonna be ethyl propanoate. Ethyl space propanoate. We move on to part D. In part D, they said locate the structure of product A. Whenever you're doing the structure, remember, the structure is the opposite of the naming. The structure is always the acid first, and then you add it to what? You add it to the alcohol. So that means what? That means when you're doing the structure, you will have 3 carbons first, okay? And then, in the second part, after the ester bond, remember the ester bond looks like this, double O, single O. This is what the ester bond looks like. So after this, you will have what? You will have 1, 2 carbons, okay? So if we're gonna go here and we're gonna look at them, I'm just gonna go to the answer directly. You're gonna first have the acid. The acid has 3 carbons, that is good. And then you have what? You have the ester bond, perfect, that's amazing. And then you will have 2 carbons after that, so that is perfect. So this one is gonna be our answer. Now, choose the name of the carboxylic acid and alcohol that react to form compound B, knowing that compound B has the same molecular formula of compound A. If compound B has the same molecular formula of compound A, that means it has the same carbon number. We know that it has, compound A, a carbon number of 1, 2, 3, 4, 5. So you will need to add them all together until you get one that has 5. Meth is 1, prop is 3, 1 plus 3 is 4. But is 4, F is 2, 2 plus 4 is 6. F is 2, prop is 3, 2 plus 3 is 5. And then F is 2, meth is 1, 2 plus 1 is 3. So the only correct answer would be then C. We move on to question number 16. In question number 16, they said, choose the name of the process occurring at each step of the given water treatment course. So, in step A, what do we have? We have first water plus bacteria plus large solids plus fine solids. You got rid of what? You got rid of the large solids. When you get rid of the large solids, this is known as screening. Then, step B, what happened? You were with water, bacteria, fine solids, you got rid of the bacteria. Getting rid of the bacteria is known as sterilization. And then in part C, what happened? You got rid of the fine solids. When you get rid of the fine solids, this is known as filtering. So in order, it's gonna be screening, sterilization, and filtration or filtering. Now choose the step that involves the addition of chlorine or exposure to UV light. Chlorine, UV light is gonna kill the bacteria. Killing the bacteria is sterilization, so it's gonna be step B, very simply. We move on to question number 17. Upon the addition of water, the solid color changes from white to blue. From white to blue, very important. First thing we need to know is that when you add the water and it changes color, the first thing that it is anhydrous. Very important. So if you open the options, you're gonna ignore everything that is not anhydrous, okay? Next thing, when it goes from white to blue, it is gonna be what? It is gonna be copper sulfate. So it is gonna be anhydrous copper sulfate. So for part 1, it's anhydrous copper sulfate. For part B, upon addition of water, that means directly it's gonna be anhydrous. So you're gonna remove everything that's not anhydrous. And then it's gonna be what? It changes from blue to pink. When it changes from blue to pink, you know that it is anhydrous cobalt chloride. That is it. We move on to question number 18, the very last question. Drag and drop the terms below to determine whether each of the following reactions is spontaneous or non-spontaneous based on the trend in reactivity of halogen. So, in order to remember this, remember fickle Brie. So, fluorine can displace chlorine, bromine, and iodine. Chlorine can displace bromine and iodine. Bromine can displace iodine, and that's it. Iodine cannot replace any of them. So what do we mean by replacing? We mean that if you find the stronger one in an element, so for example, in this case, Cl2, and then you find a weaker one in an ionic compound, for example, Ki, then definitely for sure it's gonna be a spontaneous reaction because the Cl2 will be able to displace the Ki. So it's gonna be I2 plus 2KCl. This is definitely a spontaneous reaction. Based on this, let us see. I2 cannot displace anything. So directly, whenever you see I2 as a compound by itself, then you know that it is non-spontaneous. Br2, let us see. Br2, can it replace Cl? Based on fickle Brie, no. Br2 cannot replace Cl. So definitely this is also a non-spontaneous. So let us submit and hopefully we don't have any mistakes. And great, thank God we don't have any mistakes. Thank you guys for watching. I hope you enjoyed and have a wonderful day.